Today I'm going to be talking about the basics of Next.js, and then we'll look at some exciting new upcoming features in both Next.js and React. React has gotten increasingly popular over the last few years, and to the point where a large percentage of web developers are using React or have used React before. This is further confirmed by various metrics, so let's have a look at some of these. MDN released the first edition of their developer and design survey to try and learn more about the needs and frustrations of developers. With over 28,000 responses, one interesting result was that 72% of respondents actively use React, Angular, or Vue to build out their websites. Furthermore, more than 350,000 sites are running React based on HTTP archive. So HTTP archive is this library of sites being indexed, and it can tell which client-side framework is being used. And 350,000 of those sites are using React today. But building React applications is still hard. Saying I'm going to use React is not enough to get started. You have to set up build tooling, and there's all these pitfalls you have to consider to make your application slow. You need to ensure that your project can scale to many views and pages if your application is going to grow over time. And you don't want to rewrite your application every single month or every other month in order to stay up to date with the latest features and releases. So you want to focus on building out features. In reality, this has gotten easier. A new type of tooling has risen to popularity in the past 3 years or so. Frameworks that are built on top of UI libraries like React. The main goal of this class of framework is finding the sweet spot of providing the best user experience to end users, but also making your team more productive in creating features and deploying them to production. Combining great UX with amazing DX. The Google Chrome team calls this type of framework a web framework, an end-to-end system that controls every aspect from getting started to everyday development and deployment. It's positioned to directly impact UX and developer experience by controlling the server, client, building and serving your application, and also development and production. Enabling developers to successfully build and maintain high-quality production web apps. Web frameworks are positioned to inform performance. So in addition to developer productivity, web frameworks can directly impact performance and user experience because they have opinions about server-side rendering, flushing early HTML chunks, and streaming. And they control how the application serves JavaScript, CSS, data, and images. And it unlocks new features like progressive delivery and lazy fetching. And it's not just about scaling in application size or users, it's also about scaling your team. When rolling your own solution, you have to keep in mind that many different parts all have to play together. So this goes from UI component model to routing, to the data flow of your application, to compilation, bundling, pre-rendering of HTML, and a whole bunch of other things. And this is where Next.js helps you. Next.js is the web framework for React. It allows your team to focus on building your product instead of build tooling. It comes with opinions on how to build your application, and these opinions are there to put you in the pit of success while providing great developer experience and user experience. So today I'm going to focus on some of these topics. So let's dive in. So first, the UI component model. It allows teams to share UI elements and basically components between views. Generally, this is handled by a UI rendering layer, like React, for example. Then there is routing. So web applications can consist of many pages. It's not just one page in general, it's generally way more pages than just one or a few. For example, marketing pages, a blog, dashboard, etc. Routing influences more than you think. For example, your codebase needs a way to express what a route is, how to link to a route. What if I want to do single-page application type client-side routing? Or routing affects bundling as well. Like you have to ensure that you're not sending all the routes in your application if a single user goes to your about page. You don't want them to load your dashboard and all the other pages that you have inside of your application. So routing influences end user experience as well. When a user clicks a link, they expect to see a result, and they expect that result to be very fast. So what does that look like in your code base? So in Next.js, you create routes through a pages directory. It's automatically based on the file system, and it makes it simpler to reason about the code base and where to find a certain route. So one example is pages about.js automatically becomes /about, and blog slug with brackets.js is going to route to blog/hello world, but any other pattern as well. So what does a page inside of Next.js look like? It's just a React component. You export a plain React component, just like you've used in other React frameworks, and you'll automatically get that served on /about in this case. And then Next.js also does automatic code splitting. So pages are automatically split into different JavaScript files by default. This avoids the pitfall of sending the whole application bundle, including all routes, to the end user when you just want to view that single about page. So teams can independently work on pages without hurting each other's performance as well. For example, if someone decides to import a large library in the blog page, it won't affect the about page. Client-side routing, like a single-page application, is also possible. You can use the next link component to link between pages, and those won't go to the server to then load the whole HTML again. They will just render the single React component that has to be rendered and automatically go to that page by default. It also has built-in prefetching, which allows for basically prefetching the URL before it actually has been clicked, allowing for a faster transition to these other pages. And it does that based on the viewport, so only the links that are inside of your viewport are going to be prefetched in that way. And it also disables that prefetching if your network is slow. So it won't affect slower network connections in this case. Then there is pre-rendering HTML. Pre-rendering HTML allows search engines to index the content on the page as it's part of the initial HTML sent to the browser. This allows for meta information to be shown inside of Twitter, for example, through open graph tags. So like in this slide, you can see that there is an image and some title and other information there, and that can be automatically inferred by Twitter by fetching that URL. And this is what server-side rendering allows. It also allows for displaying content faster. So let's have a look at what that looks like. In the example you see, there is a difference between standard React app without pre-rendering and a app with pre-rendering. This video was made by the Google Chrome team, and as you can see, the React app with pre-rendering shows content significantly faster. So pre-rendering HTML has two forms. There is static generation, SSG, or server-side rendering, SSR. SSG runs at build time, and it allows the HTML to be served from a CDN automatically. JS and data can be prefetched in that case. In the case of server-side rendering, it goes on demand. Every time a request comes in, the user is going to get a specific version rendered for their specific request. And it requires runtime execution. So you have to host a Node.js server or Node.js functions in order to be able to use server-side rendering. And JS can be prefetched. So not the data, but the JS can be prefetched in this case, because otherwise every single user would actually prefetch too much data that would potentially hurt performance for the servers that you're hosting on. So let's have a dive into static generation. So static generation runs at build time, like I said, and can be served from a CDN. And the way that you do this inside of Next.js is using getStaticProps. So getStaticProps is a top-level function that you can export that allows you to return properties, and it allows you to fetch some data from somewhere, like a CMS, some other data source like a database or anywhere else. And then those props that you return are then fed into the React component that you want to render. You can also use dynamic routes with static generation through getStaticPaths. So getStaticPaths actually allows you to return a list of pages that have to be pre-rendered based on a dynamic route. And then every single getStaticProps call is going to get a parens object that allows you to get a post for a certain parameter. Static generation in Next.js also has support for preview mode, which shows the updated content to editors immediately. So maybe you have used the CMS before, and sometimes like making a change inside of the CMS has to be shown immediately to editors so that they can preview their changes in production. So in order to see if the lines are correctly outlined and all that. Preview mode allows you to do this with static generation. So you can statically generate pages at build time, but still bypass the static generation for those particular preview mode users. And this works with any data source. I have a demo for this particular feature, and let's go through this together. So this is a static website that uses Next.js preview mode. It's a website that is completely statically rendered. As you can see, it has a cache hit from a CDN. And every time you hit that site, it's going to have that cache hit. However, you can still make edits. So maybe like I want to say, like this is not my static site, but this is my site. So my site by Tim Neutkens. So then I want to share this edit with one of my colleagues, because maybe they want to see those changes as well. So what you can do is you can basically then share this link with these colleagues, and those will bypass the static generation of the site, while all the other users are still being served with this particular static website. So my site by Tim Neutkens. If you then go back and you look at the at the main website again, so you go to another tab, for example, you'll see that it still shows my static site. This is because it didn't update the actual site. It actually updated the entry inside of the CMS for others to be shared. So it's a preview of the URL. It's not the actual URL that users are going to see yet. So then like after my colleague has looked at it and they find it like a good edit, they'll approve it and then be able to like merge it into production and go from there. So let's get back to the slides now. Then there is incremental generation. It's enabled by fallback true, which means that if you want to generate other pages that haven't been generated at build time, but still have them statically cached at the edge, like at the CDN level, you can still do that in Next.js. You do this by returning fallback true. And I also have a demo for this, and let's go through that as well. So this is a static tweet demo, and what this allows you to do is statically generate new tweets as a shell of HTML, basically, by just appending a URL, appending a Twitter ID after the URL. So an example of this is, like, you can get a random tweet here. You can open that in a new tab. And then you'll see a introduction to a game dev, some like tweet that has been generated. And this tweet is statically inlined. So what this means is it has been statically generated, and you can find it inside of the HTML here. So like the game dev part, etc., is all inside of the statically generated HTML served from a CDN. So that is what incremental static generation allows. By using fallback true, it's going to automatically allow you to generate new pages even after build time. So let's get back to the slides again. Then there is incremental static regeneration, which allows you to regenerate some content that was built at build time. So say you want to make some updates inside of your CMS and you save those. Those still have to be shown in the website after it's being built. Otherwise, you have to rebuild your application every time there is a content change in the CMS, which is definitely not something that you want to do because that can take way longer than just regenerating that one page. So Next.js allows you to regenerate this single page based on an interval. So you can return a revalidate 1, and then every second after a request comes in. So it's not going to hurt performance for a single user. It's going to always, like in the background, regenerate the page based on requests that came in. So no rebuild is required. So let's have a look at server-side rendering. Server-side rendering is on demand, like I said. So every single request that comes in is going to be a new render of this particular page. This will allow you to change certain data points based on the incoming request, like someone that's logged in or not can have different results based on if they are logged in. So the way that you do this in Next.js is using get server-side props. So get server-side props works in almost the same way as get static props. The only difference is that it runs on demand for every request instead of at build time. And all of these data fetching methods, so get static props, get server-side props, get static pods, are eliminated from the browser bundles. This allows you to do direct database queries, which means that you can access some database through, for example, Prisma or other solutions without having to make sure that it works in the browser. So all you have to do is make sure that it works in Node.js, and then it's going to work across all navigations and every single rendering method. So what this looks like is basically you use get server-side props, and then that is the specific Node.js code, but that specific method and everything that it imports, so every function that it imports, every variable that it references, is being removed in that particular page. So you basically get a browser output of just the React component in this case. And in Next.js, you're not forced to use a certain method. So you're not forced to use static generation for your whole website or forced to use server-side rendering for your whole website. You can build a hybrid application that can be static and dynamic at the same time for different pages. So for example, your homepage could be static and coming from a CMS using revalidate, or your about page as well, but then automatically because you don't have any data that you want to fetch. But then your blog actually needs some list of posts that you can use get static paths for, and then get static props to fetch the data. But your dashboard could be highly interactive and differ between users, and that would allow for server-side rendering, for example. So you can still use server-side rendering and static generation together in the same application, by just using these different methods between pages. So you don't have to choose at build time, okay, I'm going to statically generate the dashboard as well. You can just say, okay, I'm going to server-side render the dashboard. I'm going to use the blog as a static generated site, and so forth. The Next.js team is working with the Chrome team. So at Chrome Dev Summit in 2019, we announced that the Next.js team is collaborating with the Google Chrome team on various performance-related efforts in order to basically move the needle on React applications out there that could be improved in performance by just upgrading Next.js, for example. And this relates to another thing that I wanted to talk about, which is core web vitals. In case you haven't heard of core web vitals, I would suggest that you have a look at web.dev/vitals, which clearly explains all the differences between core web vitals, but the most important ones are largest contentful paint, first input delay, and cumulative layout shift. So largest contentful paint is the largest element rendered on the screen, and then the time that it took to render that. So for example, a large hero image inside of your website on the homepage is generally going to be the LCP element, which means that the time measured for LCP is related to that image being loaded. Then first input delay is the time it takes for input to be interactive, basically. And then visual stability, so CLS, cumulative layout shift, helps with detecting like jumps inside of a page. For example, like you've all seen this before, where an image is loaded and then it suddenly like jumps all the way down to the content that you've been reading. So all of these together, core web vitals, LCP, FID, and CLS, are going to be used in Google's search ranking algorithm, starting from May this year, which is very important because this is a very different way of indexing based on performance for your application. It's very much based on real user data, and you have to make sure that your LCP, FID, and CLS are inside of the good green zone, basically. So before 2.5 seconds for 100 milliseconds and 0.1 for CLS. For example, if a page jumps around very much, it's going to get a much higher CLS value. And this is where Next.js helps you, because we have some APIs introduced that ensure that your LCP, FID, and CLS are optimized. One of such examples that we worked on together with the Chrome team is Next.image. So Next.image is a image component for React that you can include inside of your Next.js application. And it does a lot of the best practices for images by default. So if you create an image that has like profile.png in it with a width and height of 200, it's going to automatically lazy load that image. It's going to optimize the image, so you don't have to think about, I need to like optimize my images because like users are uploading it in a much higher size or something like that. It also is going to automatically serve it in WebP to browsers that support WebP, and it also prevents layout shift. That's why the width and height are required in certain cases. You can still opt out of this in certain ways, like using different layouts. But I'm not going into that today. You can check that out into the documentation. So it prevents layout shift by making sure that the space needed to render is already there before the image loads. It also optimizes for largest contentful paint through a priority attribute. If you add a priority attribute, as you know, the like largest image on the homepage inside of the initial viewport, so like a hero image, is the LCP element. You can say, okay, optimize loading this for me, please. And then Next.js will automatically preload it and make sure that it's loaded faster. Another thing that we worked on together with the Chrome team is Granular Chunking. So this is an automatic optimization that all Next.js users get just by upgrading their Next.js application. And it allows for smaller bundle sizes without any like negative side effects inside of your application. So all you have to do is upgrade Next.js in order to leverage these improvements. So the Chrome team helped us introduce this new JavaScript code splitting strategy, which led companies to see major improvements without any code changes. For example, Barnaby's had a 23% decrease in application size, and SumUp had a 70% decrease in their largest JavaScript bundle size. So all they had to do was upgrade Next.js in order to leverage these optimizations. And we're committed to keep making these types of enhancements automatic for developers so that they can just upgrade and leverage these optimizations. We're also collaborating with the React team at Facebook. So we worked on various different features together with them. And the first one was React Fast Refresh. So we brought React Fast Refresh into open source, which this was being used inside of Facebook for quite some time. And we implemented all the like Webpack layers and everything else that you have to think about for compilation of React Fast Refresh. But in practice, it's going to allow you to use React components and state, especially, that is then like tracked over time. So for example, if you make any changes inside of your components, you don't have to think about refreshing your page in order to see the updated changes, but also the state is being kept across those changes. So for example, in this example, you can see that if I click me many times, it's going to show you the increase in the amount of like counter that we have. And then the counter is incremented over time. But if you still change something inside of that particular file, it's still going to keep that count across like hot module replacements, basically. So this is what React Fast Refresh helps you with. And then there's another thing that we're working on together with the Facebook React team, which is zero bundle size React server components. So what React server components allow you to do is fetch data inside of a React component. Previously, you had to use get static props or get server-side props in order to leverage these optimizations. And the best thing about this is that server components do not affect client-side bundle size. It allows you to create components that are only rendered on the server and don't send any JavaScript to the client side for those particular components. And it's still in R&D, so don't feel like you have to learn it today, but definitely keep an eye on it. And it will be deeply integrated into Next.js as we're working with the Facebook team in order to bring this to open source. So how can you prepare for React server components? Well, server components are still in R&D. There are 2 steps you can take to ensure an application will be ready when when server components become available. Enable React strict mode and upgrade to React 17. Once you do these 2 steps, you make sure that your application is ready. And in order to stay up to date on React server components, you can follow me on Twitter and learn more at vercel.link/RSC, which is a blog post outlining everything that we're doing inside of Next.js in order to prepare for React server components. If you want to learn more about Next.js, you can go to next.js.org/learn and go through an interactive tutorial that guides you through every single step from setting up a Hello World Next.js app to building out a full blog. And also how you can take that further after you build that whole blog as well. Thank you for having me and have a great day.